about how we talked about quantization of electric charge. We talked about the law of electricity, the fundamental law of electrostatic, the fundamental law of static electricity. We mentioned it. We talked about the conservation of electric charge, and there is a law for that. We stated the law with explanation. We talked about how ebonite rod gains electron, so becomes negatively charged. How glass rod loses electron and becomes positively charged. And I think we still mentioned some few things. We've talked about Coulomb's law, a very, very important law in electricity. We mentioned it. We talked about, or let me just say electric charges. So we talked about, I think we stopped at Coulomb's law. Yeah, I think we stopped at Coulomb's law. We'll be taking one last thing that will make the first unit to finish, and we're entering the next unit of that module. I think it should be electric field. We haven't talked about electric field. We haven't talked about electric field intensity. All right, if you're with me now, if you think we should start, let me see your reaction. I will not I really want to start today's explanation. No reaction at all. Okay. Oh, okay, she just entered. Hello.
Sorry, you wrote physics 132.
Electric field intensity. Simply electric field. They call it electric field simply. So when we talk about electric field intensity, practically, it is talking about the extent at which the effects of an electric charge can be felt to. The extent, that means the level we can feel this charge to. Once it passes this level, it's no more in that field. It's no more in that electric field. Something outside that level, something outside that place will not be under the influence of that charge. So now I'm explaining it practically. If this was an electric charge and this is the field of the electric charge, then something outside here would never have an effect on it. For now, if there is another charge here, then around between them is the electric field. So the electric field will be felt. So practically, electric field is just the region where the effects of that charge would be felt. But when we're talking about electric field now, we say electric field is the force over charge. That is ratio of force over charge.
Please mute your mic.
Definition of electric field is the unit per charge. The force per unit charge. That is it. That's what we call electric field. So I think here now, listen, we said force, electric field is force per unit charge. That is F over Q. So I need you to be very attentive now. We are going to do some interesting maths here. Electric field equals force over Q. Now remember the force in an electric field. The magnitude of the force is given by the Coulomb's law. That F is showing here equals 1 over 4 pi epsilon naught Q1 Q2 over R squared. I entered the group and I encountered an argument. Somebody was saying is B, somebody was choosing D. So it's actually B, that question I saw there. It's B. Because the force is directly proportional to the product of the masses, to the product of the charges, and inversely proportional to the square of the distance between them. So it's never D if Olabi is here, and some other people that chose D. Okay, F is this according to Coulomb's law. Now we are going to enter the value of F here. So E is going to be equal to enter the value of F truly. Q1, Q2. We are taking it as a whole Q. Q times Q, that is Q squared. You might not be interested in derivation of formulas, but at least there will be one or two persons here that will be interested. So let me just go through it. It's not so hard. Over Q, so that is 1 over Q. So 1Q cancels the square here. Then the formula for electric field intensity, as important as it is Q over 4 pi epsilon naught R squared. If you don't know this fundamental formula now, you're going to suffer a lot while encountering the problems. So that is the question. That is the formula, rather. E, which is the electric field intensity. I don't know why in the material they really like calling it electric field. Electric field. It's the same. The electric field is equal to Q, which is the charge in that electric field. They will be talking about a single charge this time around, over 4 pi epsilon naught R squared. So 1 over 4 pi epsilon naught being the Coulomb's constant, and Q over R squared. E equals KQ over R squared. So that is that as per that. Don't forget the formula. We are going to work with it now. Electric field intensity. This is the formula for it. E equals F over Q, or E equals Q over 4 pi epsilon naught R squared. The both of them are very important. It's funny now, my brother is using my system. Is there anyone that can help me with some questions from that place? I would have loved to get questions. I can't form a question in my head for this one. But let's see if I E equals F over Q equals 4 pi, 1 over 4 pi epsilon naught R squared, Q over R. So it's the same, 1 over 4 pi is 1 squared, not R squared over Q. So let's say question says, is there anyone that can help me look for a question over there? B. It's not so easy to form a question for myself. I'm going to be having values. I can even be having negative value when I'm supposed to be having positive there. I have to go through the workings before I can set a question like that. Anyone with the problems? Is there anyone that has an example under electric field here? Just read it out, please. Aminat. Please be fast. Don't let us waste time. Is there anyone with it? Kingsmate. Amina, you don't have.
Yes.
I said check now.
Check I'm not with you. Okay, I'm coming.
Just read the question. What does it say? Amina. Time is going, Jerry.
Let me read one.
Please do that.
A charge Q1 equals
I can't hear anything. Or you just type it. We just type it. Oh. What are we going to do now? Time is going. We are doing nothing.
Can you hear me now?
I can hear you. Okay. I can hear you now.
Can you hear me?
I can hear you now. Yeah. I can hear you. Okay. I've seen one here, guys. So this question says, calculate the electric field intensity. This is the question I have here. Calculate the electric field intensity in vacuum at a distance in vacuum at a distance of 10 cm from a charge of 5 times 10 raised to the power of minus 10 coulombs, minus 4 coulombs rather. Take 1 over 4 pi epsilon naught as 9 times 10 raised to the power of 9 coulomb square Newton per meter squared. Okay, can we all see this question, guys? Here is the question here.
Yes, you can see.
Please, let's be fast with it. So we'll solve it together. So you've been typing since. Thank you. Are we together? Shall we just solve it now?
Yes.
Yes.
The question says calculate the electric field intensity. I'm quite glad some people have understood the Coulomb's law, how to work with it. So we are going with this one now. I want you to be very sure you get it too. So it's not something hard. Just concentrate, guys. I wish you the best. The electric field intensity is what we are looking for. So that is E. I don't know it. In a vacuum at a distance of 10 cm, the R means R is the distance. Okay, no. R is the distance from a charge of this. So distance of 10 cm. R is representing our distance. Like let's say like radius. It's not radius, but we are using it like that. So R is representing our distance, 10 centimeter. From this of 5 times 10 raised to the power of minus 4 coulombs. That is the charge. 5 times 10 raised to the power of minus 4 coulombs. So guys, we have this given, we have Q. So our R now is not in the SI unit, right? The SI unit of distance is meter. And the unit we are given here is, I think this thing is not showing up. I think the reflection is exactly here. So Q equals 5 times 10 raised to the power of minus 4 coulombs. So our R is in 10 cm. What do we do to make it to be in meter? I think I treated this in the last class. Anyone? Anyone? What do you say? Aminat?
Yes, by dividing it by 100.
Dividing it by 100 or multiply it by 0.01. So 10 raised to power 100 centimeters make 1 meter. So dividing 10 centimeters by 100, we're going to have 0.1 meter. That is that, 0.1 meter. So we are looking for that value now. We are given K Coulomb's constant. Key, don't forget the formula for intensity. It's very simple. Just like formula for force. Just this one is just 1 Q. That is the difference. Note that thing. It's only 1 Q. That's the logic there, guys. I showed you how it's being derived now. But if you don't want to know how it is derived, you want to forget about that. Just know that this one is 1 Q, and that is the only difference between them. Q over 4 pi epsilon naught R squared. That is, what is my Q? Given to be 5 times 10 raised to the power of minus 4 over 4 pi epsilon naught. Okay, I've forgotten 4 pi epsilon naught is. That's what you should never forget this. Let's make it okay. 1 over 4 pi epsilon naught is 9 times 10 raised to the power of 9. Don't write it as 1 over 9 times 10. No. So you can as well be writing your formula this way. 1 over 4 pi epsilon naught q over r squared. So you will not be confused. You know that all these things is representing 9 times 10 raised to the power of 9. Mute your mic, please. Is this not this woman? You know, let's mute your mic. Last semester, that was how you told us. Okay, the person is saying I'm so fast. Listen again, please. I said the electric field intensity is what we're looking for. Key. The radius is given intensity. You will not get it. Mute your mics now. You will not get a perfect answer until you convert it to the SI unit. That is from 10 cm to meters. Divide it by 100. Cm to meters. Divide it by 100. And that is going to give you 0.1 meter. So Q is 5 times 10 to the power of minus 4 coulombs as given from the information. So we're looking for E. Taking the formula, I said the only difference is that we have one Q here instead of two Qs for force. You know the formula for force, F equals Q1, Q2 over 4 pi epsilon naught r squared. But this time around, we have one Q because it is the electric field intensity. It is the whole force per charge. One charge cancels one charge. That's it. Okay, 1 over 4 pi epsilon naught is given as 9 times 10 raised to the power of 9 times, what is the Q? The Q is 5 times 10 of minus 4 as given over r squared. What is r? 10 raised to the power minus 1. That is 0.1. You can write it as 0.1. Don't disturb yourself. So 0.1 squared is going to be 0.01. I want to write it as 10 raised to the power minus 2. They are the same thing. Stuff like this, you should not be confused at all. The calculator serves you well over stuff like this. So I'm saying, is it showing? I think I just said one.
Please, I have a question.
What's your question?
This since we are looking for 9 times 10 raised to the 9, you need to be at the time.
I can't hear you. I can't hear you. I really can't hear you. Maybe because of time. I can't hear you. So,
can you hear me?
Okay, I can hear you now.
I said, since we are looking for E, then the equation is 1 all over 4 pi equals to 9 q all over r2. So since we are looking for E, why is this 9 times 10 raised to power 9 at the numerator?
That is what I'm saying. I explained it severally yesterday. That the whole of this thing, this 1 over everything, it's not ordinary. You can see what is written here. And even they said 4 pi epsilon naught equals to 9 times 10 to the power of 9. That is when we'll be putting it under. We'll be putting it below the line. It will be a denominator. But right here, it is given us the whole of this. That is 1 over 4 pi epsilon naught. Everything here is equal to 9 times 10 to the power of 9. They didn't say 1 over. They didn't say this one is only 9 times 10. That will now come and put the 9 times 10 under. What they are telling us is that the whole fraction here, 1 over 4 pi epsilon naught, is known as the Newton's Coulomb's constant. The whole thing here is known as the Coulomb's constant. And the Coulomb's constant is 9 times 10 to the power 9. Maybe if you don't want to be confused, if you would prepare it that way, what we are doing here is E equals KQ1 Q2 over R squared. And K is given as 9 times 10 to the power of 9. That is what we're doing. Now just enter it. 9 times 10 raised to the power of 9 times, because of E is just 1 cube here, times Q, which is given over R squared. Do you understand now?
Yes, thank you.
Okay, the calculator guy, please solve this one fast. It shouldn't be a problem. We should have 4.5 times 10 raised to the power 6. So we should have 4.5 times 10 raised to the power of 4. Okay, 8. 8 newtons per coulomb. It is very important to know the unit. Newtons per coulomb. Are we together, guys? Did we understand this, or I should come again? Please let me know. 1, 2. Three people got it. Guys, please respond if you are getting this thing. Don't just
Yeah, we got it.
Just unmute your mind. Just show its reaction. So that's that as per this. We're taking a question. I'm taking one more question. Don't forget, the units in electric field intensity, we have 2 units for it. It's either newtons per coulomb or volt per. But for now, you'll be dealing with newtons per coulomb. So the unit of electric field is newtons per coulomb. I have one more question. I can form that one.
Please, I'm somehow not this 10 raised to power minus 2. How do we get it?
Okay, like 10 raised to power minus 2 was here, and 10 raised to power 6.
Yes.
This is indices law, indices. 10 raised to power 6 divided by 10 raised to power minus 2. The law of division in indices says that if we have two numbers, 2 different indices with the same base for different powers related with the division sign, then it's going to be one of the bases 6 plus minus 2. 6 minus 2. Please, that is your mathematics. So it will really waste our time here. Just use your calculator for when we get to stuff like that. You can be using your calculators. Okay, another one here now is we're still talking about the electric field intensity. We're given the force that occurs in an electric field is given to be 1,000 newtons, and the charge upon which this force acts, is known as 1.6 times 10 to the power of minus 19 coulombs. This is the that can tell me that charge that has this magnitude. What charge has this magnitude? This is the charge of what? I mentioned it last. Charge of what? Anyone? Electron. I think that's what you said. If that's it, you are very correct. It is the charge of electron. 1.6 times 10 to the power of minus 19 coulombs, and it is the lowest charge discovered. Okay, we're looking for the electric field intensity now. E is unknown. We're looking for E. To get E, we know the formula that electric field intensity is equal to force over charge. These are the things that might probably come out of exams. Stuff like this. What is F? F is the force given. That is 1,000. Is what? 1.6 times 10 plus 19. So I'm going to have perhaps 6 point something. So let me approximate to 6 times 10 raised to the power of 21 newtons per coulomb. This is the most important thing here. I'm approximating to 6. It will be more than 6, maybe 6.4 something. But are you getting what I'm doing here, guys? What did I do?
Yes.
I just took the E equals F over Q. Finish. F is given as 1000. So a friend of mine mentioned it in the morning that he's having issues with knowing formulas. Yeah, cramming formula is not an option at all. No, you can't cram formula. How many formulas do you want to cram? So that is why physics is understanding. You have to understand it. Mathematics, understanding. So I don't know any formula offhand. When I want to use them, I derive them. So in a fraction of second, like in less than a second, I will derive it in my brain. That is the best way to get formulas in physics. Because I want to cram this formula, you definitely put it the wrong way next time. It happens even to me very well. Any formula I cram, I'll put it wrong first before correcting myself. So there is one thing, we call it dimension. Once you understand dimension, it makes knowing formula easy. Just with the unit of, let me give you one trick. Just with the unit of electric field, E, the unit is what? Newtons per coulomb. That is why you encounter questions like this in OBGYN, you will be unable to solve it, looking for formula. Oh, no, just listen. Newtons per coulomb means what? What is Newtons? Is the unit of force. What is coulombs? The unit of charge. That is force per charge, force over charge. You've derived your own formula by yourself. Is there anyone that agrees with me? You've derived your formula right away. Let me show you another thing.
I understand.
What do you say?
I understand what you're saying very well.
This is another form. This is another unit. I said electric field has two units. The first one is newtons per coulomb, and the second one is what? Volts per meter. Look at it, a very common thing. I think a question like this was sent to me some days ago. I met it as message. So, E volts per meter means what? Volt is what's volt potential difference. Let me call it B, and over meter is what? Distance. So E equals B over D. This is another formula. This is another formula for electric field. And like this, you can know formulas. So it depends on how you have an understanding about it. Okay, that's that about electric field intensity. We've mentioned it. I said electric field at a point is the force per unit charge at that point. That is the definition, no other definition. The simplest definition and the most comprehensible one says it is at a point, the electric field at a point is the force per unit charge at that point. Finish. I could remember vividly. Now, somebody reminded me that we didn't touch superposition of forces last class. Let me mention it now before entering the next thing. I think that will be Gauss's law. Superposition of forces. So in superposition of forces, normal thing. See, I have more than two forces now. You know, before there is one force. I have more than one forces rather. There is this charge. Okay, I have more than two charges. This is Q1. This is Q2. This is Q1. This is Q2. The force of electrostatic that is between the both of them is known as F. But this Q1 is having another force, another charge, Q3 somewhere again. Then the force of electrostatic that is between this one, I can say this is F1 and call this one F2. So the law of superposition now says that if there is more than one force acting on a charge, if there is more than one force, I have two forces already here, acting on a charge, then the forces can be added. If you are writing it down, you can put it down. It says if there is more than one charge, that is, there are about two charges or more, acting, more forces rather, if there is more than one force, if there is more than one force acting on a charge, there is a force from Q2, there is another force from Q3 acting on only Q1, then the two forces can be added vectorially. The two forces can be added vectorially. That's it. The law of superposition says this. So how do we solve with superposition? Look at it. I pray we get to encounter things you guys are solving for. In exam, that's what I mean. So there are three forces given by this. This is a force of 4 newtons. This is a force of 5 newtons. This is a force of Q2 of 10 newtons. Let's say this force is negative, plus. So this, I'm writing the question out. I'm only writing the question out now. So this is force F1. This is force F2. This is force F1. This is force F2. Now, what is the resultant force? That will be the question. What is the resultant force? This will be the resultant force acting on charge Q. This is Q1, Q2, and this is Q3. Acting on charge Q2. What is the resultant force acting on charge Q2? Okay, I'm only going to show you the way to do it. I will not do it for anyone. I know I have very smart guys here. Yeah. So I'm going to show you how to do it, and you go ahead with it. This is a charge Q1. This is another charge Q2. A force F exists between them, and the Coulomb's constant, which is 1 over 4 pi epsilon naught, is 9 times 10 to the power of 9 Coulomb squared per Newton per meter squared is given. The distance between Q1 and Q2 is given to be 3 meters. The distance between Q2 and Q3 is given to be 4 meters. Is given to be 4 meters. So now, use the Coulomb's formula to calculate the F here. That is F1. Use the formula to calculate F1. And use the formula to calculate F2 too. That is, the distance between this one and this one is 4. So find the force between them. Find the force between these ones too. After getting F1, getting F2, I'll tell you the next thing to do. Let's see the formula is going to get F1. I'm going to get F2 too. Guys, I'm waiting. You guys should challenge yourself with it. Do it. The distance is given. That is R between Q1 and Q2. F1 is what you're looking for. Use the formula. Q1 is given to be minus 5. Q2 is given to be plus 10. The force between them is force of attraction. And the distance is given. So please, I'm waiting for your answer. Blessing the powerful. I don't get what you're saying here. Was that a mistake? I hope so. Prodigy, you are here. Mr. Edwan, I greet you, sir. I'm waiting for you guys' work. Amuche. Smith, Maki, I'm waiting for your work. Mr. Raphael, Aminat. Mr. Ugo Chukwu. Mr. Abel, I think you guys are always in this class. I happen to be knowing your name already. Maki, Simiri. Wabu. I don't know the answer yet. Tell me the value of F1, tell me the value of F2. I think I should solve it here too. I'm waiting for you guys. Find F1, find F2 too, and I'll tell you the next thing. I'm going to use that next thing I'm telling you to explain the principle of superposition very well. What do you get? 5 times 10 raised to the power of 10. I don't know. Marky Frosh, any question? Any question, Marky? Raise your arm. Marky. Listen. As I just raising hands on questions. F2, F1 minus 5, F2 2.25. I think, is it everyone that is attempting this thing now? Let me give a minute more. Then we'll just have to do it together. Since just about 3 people answered. About 3 people or 4 people just did it. What about the others? Use your calculator to calculate. No, you don't waste much time. Now you're okay. Find F1, find F2. Even if it's only F1 found, let's know the value. All right, guys, let's work together. I said F1 is what we're looking for first. And F1 is the force that exists between the charge minus 5 and 10. So with the distance, 3 meters, we have the formula to be Q1 times Q2 over R squared multiplied by the constant. So what is the constant? 9 times 10 raised to the power of 9 times, what is Q1? Minus 5 times, what is Q2? 10 over, what is R? R is the distance between the distance that separates Q1 and Q2 is 3 meters. That's 3 squared. Okay, we keep going and say 9 times 10 raised to the power of 9 times, okay, this is 3 squared. So 3 squared is 9. Just let me write 9. So 9 cancels 9, right? So I have minus 5 times 10 raised to the power of 10 newtons. Don't be confused in any way. Once you have something like this already, this one here, you can use your calculator to solve your problem. Don't be confused that which way did I do it. You will only be asking me more questions and it will waste our time. F1 is established as minus 5 times 10 raised to the power of 11 newtons. So Mr. Raphael, did you, or Mr. Maki, did you see it now? The standard form is very important. This is a number, a negative integer that is about 500 billion newtons. This is minus 500 billion newtons. Why the one you gave me is just minus 5 newtons? Look at the difference between minus 5 and minus 500 like that. Okay, F2 now is going to be the force that exists between Q2 and Q3. Let people know you understand what you are doing. In this case, you will not be writing F1, F2 equals to Q1, Q2 again. You know you are working with two forces, Q2 and Q3. You are working with Q2 and Q3. Let the understanding show in you. Then you write F2 equals Q2, Q3 over R squared times 1 over 4 pi epsilon naught This shows you understand what you are doing. Because the thing is labeled here. If you said Q1, Q2 again, that's using Q1 and Q2 again. Understanding matters a lot. Don't just cram. That's why I hate mathematics without knowing the essence. Why do we use this formula? Why do we differentiate? Why do we do this? So try to know the essence of everything you're doing. Even when learning, why are we learning this course? Is it for learning purpose or we want to achieve one or two things from it? Let's all know the reason we are working. It's very important. Understanding it is the key to life. Q2, I'm sorry for turning to motivational speaker. Q2, Q2 is, where is Q2? 10 newtons. So 10 times Q3 is plus 4 newtons. 4 over R squared. That is the distance that exists between the both of them. That is 16 times Coulomb's constant. 9 times 10 raised to the power of 9. Okay. 4 here, 1. 4 here, 4. So I have 2.25. That is 10 divided by 4 times 9. We have times 9. So I can as well say I have 90 divided by 4 is going to give me 22.5. I'm right. Yeah. 22.5 times 10 raised to the power of 9. So here now, I have 2.25. It's mathematics I'm doing, guys. Don't be confused in any way. Just take your calculator and be calculating yourself. I'm used to no calculator. I don't have calculators. So F2 is 2.25 times 10 raised to the power of 9 newtons. So now, we said two forces. Understanding matters, guys. Understand what we are doing here. Two forces. Prodigy, any question? Any question, bro? Any question?
The F1. Is it 5 times 10 raised to the power 11 or 10?
Where did I write it?
Thank
you, Jared.
Okay, the F2.
Thank you, Prodigy.
Okay, the F2 is 10 raised to the power 10. I thought it's it. Okay, yeah. Okay.
Now we said two forces.
Isn't that supposed to be okay?
About 10. It was a bit, I said it's a slip of hand. So F1 exists between Q1 and Q2. That is a force that exists on Q2. The force coming from Q1. Another force coming from Q3 exists between it and Q2. Two different forces on Q2, F1 and F2. So the principle of superposition says that since we have two different forces acting on this one too, then the forces can be added vectorially. What do we mean by vectorial addition of something like this? The addition law of vector says that this. I don't want to state it here again. Waste of time. Perhaps I should state it. What's the next? So, because of that, use Pythagoras theorem. Yeah, we're looking for this R. R is what we are looking for. Pythagoras theorem is as simple as saying R squared is equal to F squared, this side squared, plus F squared. That is F1 squared plus F2 squared. Please, if you didn't get what I just did now, let me know with reaction. Please.
No, I don't understand.
All right, sir. This is what we're doing. This is actually it. It's one of the basic stuffs in vector, addition of vector. You know, scalar. You can just add scalar as 3.5 equals 3. Vector will not be added this way. That's why I cannot just add this one and this one together and give me the answer. These are vectors. The triangle of vectors says that if two vectors are represented by two sides of a triangle, then the third side, these are two sides of the triangle, written this way and this way, then or this way and this way. Then the third side represents the resultant. That is the triangle of vector. The third side represent the resultant. So this is the resultant. This is the force of 4, and this is the force of 3. I'm talking about the distance between them now. Look at the distance between them. Do you understand? Then you get this one as r squared 4 squared plus 3 squared. But because you are working with the vectors, not the distance, if this is r, then this one gotten f1 is what? F1 is 5 times 10 raised to the power 10. F2 is what? 2.25 times 10 raised to the power 10. So r is going to be, r squared is going to be square of this one plus square of this one. So I'm saying that this r is equal to the square of f1 plus the square of f2. That is the law. That is what we call superposition principle. Prodigy, any question? Prodigy. Okay. So now, since we have the value of f1, f1 is gotten to be minus 5 times 10 raised to the power of 10. So plus f2 is gotten to be 2.25 times 10. So let's square the both of them straight away. Square these 2. I don't want to be wasting my space again because there's no even space anymore. This is r, right? This was r squared before. Squaring both sides, I will have my r. So do your math. The answer you established by this will be the value of the r. That is the force. That is the resultant force acting on 10 newtons. Because there's a force coming from here, another force coming from here. We can't just add them that say add this force and add it to this force. You know the total force. No, vectors are not added that way. That is the meaning. Naomi.
Sorry, please, I can't say
Hey, okay, sorry. Bella, my dear. I don't use a dollar, but if you don't finish, make I put my back.
Okay.
See you here, Naomi. And because of you, I will have more.
I'm done.
Alright, okay, my dear. Yeah, the thing will fall down. Okay. Guys, the answer you get here after doing this, you are going to have 2.5 times 10 raised to the power of 20 plus, what's the square of 20? I don't know. So anything you have at the end of the day will be the value of the whole force that is acting on R. After the force is established, that's gotten 1. So just come and draw this thing again. Confusing people. Not every one of us likes math like that. So don't let me enter it too much. Let's call it a day on superposition of force. I will enter Gauss's law and I will log out. I'm not so well. Any questions so far, guys? Please. Any question? Your question is highly welcome. Any question? Any question, guys? So I will assume everyone is getting it. All right.
Ali, what about the angle?
Ali, I have a question. Just clarification.
You waste time on the angle again. All right, if that's the case.
Hello, can you hear me, Ali?
I can hear you. What's that?
Hello.
I can hear you.
Don't clean yet, please, Ali. Let me ask question. Just want to clarify something.
Screenshot it now.
She wants to ask a question. I'm with you. Please, be fast. What did you know? I brought in front.
Ali, can you hear me?
I can hear you. Don't call me that. Now it's up.
Abigail, we can hear you. We can hear you.
I can't hear you anymore. We are speak out now. Okay. This okay. Prodigy, what did you get as the force? What did you get as the force? What is the R? Without the R, I might not be able to get the angle. I might be able to get it too.
Sorry, let me do it.
So,
I didn't stop.
guys, don't forget the triangle you have already. You had this one like this. This is this point, and this one is here, and this is the resultant. So the thing is going to be like this. This is the vertical line. Look at it very well. This is the horizontal line. If you draw this horizontal line here, then where is the resultant going to be? Keep facing here. So you have to follow the triangle law of vectors and put it this way. This one comes here. This one, let it go like this. And this resultant force goes this way. You can see they are still the same thing. If I call this my point A, O, B, then this is going to be A, O, B. So this is the R, and this is the F2, 2.25 times 10 raised to the power of 10 newtons, and this is 5 times 10 raised to the power of 10 newtons. So the angle here is the angle we are looking for, alpha. I'm very sure many people know trig ratios here. So K2, trigonometric ratios. We can use opposite over hypotenuse, opposite, but tan is better, opposite over adjacent. So you might not necessarily find the value of R. Opposite over adjacent. So tan alpha, that is 2R, is equal to opposite 5 times 10 raised to the power 10 over adjacent 2.25 times 10 raised to the power 10. So tan alpha is going to be 5 over 2.25. So 0.4. Just do the mass, and after the angle will be in degrees, will be the direction of the resultant force gotten. I mean, how was that?
Yes, what about the minor that is under in front of that?
Because I'm just labeling this one, it might not be useful. So don't worry.
Okay.
You don't have any. You just need the minus is only telling you that it's a force of attraction. You might as well not put it. It's only telling you it is a force of attraction. Do you understand? Any question, guys? Let's hear you, Naomi.
Okay, when I did my own calculations for the error, I got 3.01 times 10 to the power 21.
10 to the power 21. Okay, that's correct. It's correct.
Okay.
As your resultant force. So if you draw this thing, you can just put it here. You know, as I put 5 times 10 to the power 10 here, this here, I put it here.
Okay, thank you.
You're welcome. I know I'm still owing you, so boy. One day I will pay my bills. I will call you one day. I even called you when people subsided. I think it was on WhatsApp. You know, I left. So I only came online and I called it. I didn't pick it and I left back. So another time, don't worry. I think that's all about superposition of forces, guys. So let's clarify that point once more. We talked about electrode charges, quantization, conservation. We talked about electric field now, and we mentioned Coulomb's law, superposition. Superposition of field also occurs. So I think that's that as for that. We've taken it somewhere then. The next thing is to, let's say, just introduce ourselves to the next thing, and in the next class, we would continue with it. The value of R gotten. Now we know you talk now. Okay, R is the resultant force. It is the resultant force. That is the total force. That resultant force is the total force that is acting on that Q2. You know, a force is coming from this place. A force here. So that total force cannot be the addition, like add this one to this one. No, because they are vectors. That's why we had to undergo that process. of r squared equals to e squared plus b squared. It is cosine rule we are using. Pythagoras theorem is the same as cosine rule, but the cos theta is eliminated to 0 because cos 90 is 0. That is why. So, and it is a right angle triangle. 90 degrees is the angle. So cos 90 is 0. So the same thing. Cosine rule is the same thing as Pythagoras theorem. But those are the advantages. Okay.
Okay,
That's
thank
that
you.
as well.
Sorry, I wanted to ask about the units, not the value.
Anybody?
Like, does it have a unit? Like,
Okay, Newton. Newton, since it is a factorial addition of two vectors, addition is always associated. Okay, guys, let's talk about Gauss's law, electric line of force. Not information. Electric line of force. Guys, there is one thing we call electric lines of force. They are imaginary lines, but these lines are very important. They show us the direction of flow of electric charge. What direction is this charge going? The electric line of force is an imaginary line or imaginary lines that shows the path that a positive charge will follow. This is point A, point B, point C, point D. So the electric charge at point A is going to be tangential. There are two definitions for it. You can say it is the line that is tangential to the point. That's it. So at point B is going to be tangential. You know what a tangent is? Passing through the arc. Tangential. Tangential. So the direction of electric charge here is going to be like this. The direction here is going to be like this. Direction at B is going to be like this. Direction at A is going to be like this. What is telling us this thing? What is showing us the direction? It is the electric lines of force. So this is a positive charge now. Well, that is why the law of magnetism holds correct. So this is another positive charge. This one is like this. Because it is a positive charge, please note it. These are, let me even predict that this one will come out of exams. Too much. Let me predict that this one will come out of exams. Because it is positively charged. This is a positive charge, right? That is why electrons will be leaving. So this is the direction. You can see it is pointing outward. We call it pointing radially outward. Hey, marker to check. See new marker. We are wrong. Radially outward. So because it is a positive charge, it is pointing radially outward. That means it is losing electrons. This is a negative charge. Negative point charge. Look at where this one is pointing at. Inside. This one is taking electron inside. That is the meaning. Negative charge, sorry. So we call this one radially inward. Please, if you got what I just did, let me see your reaction, please. It is good then. Mr. Abel, your question. It is good. I suppose people got it well. Okay, so now look at the reason that this law stands right. This law of magnetism, law of static electricity. Why is it correct? Look at it very well. Look at radially outward for positive, radially inward for negative. It comes in for negative. For positive, it goes out. Now see. This is a positive charge placed with another positive charge. The positive charge is going outward, right? Going radially outward, radially outward, radially outward, outward. So this is another positive charge, and they are in the same field, the same, very close to each other. radially outward. Because they are both radially outward, pointing outward. This one will be bringing its own out. This one too will be bringing its own out. But they will never touch because this one is not deficient. It is not deficient in electron. It doesn't want electron. It wants to give it out. This one too is not deficient. It wants to give it out so they won't grieve for each other. Then this one will be, it will be bending. This one too will be bending, 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 bending. Then repulsion occurs. They repel each other. They will never touch. The line of force will never touch. Please, is there someone that got what I just did? If it was magnet, not an north pole, we will call this place the neutral point. But this is an electric charge. So are we getting it, guys? The reason that they are repelling each other is because they are both positively charged. This one wants to give electron out. This one too wants to give electron out. None of them, neither of them is ready to accept electron. So what? We'll definitely repel ourselves. We cannot touch ourselves. Please, is there somebody that got my explanation? They both are rich. Both of them are rich. So this one wants to give something out. And this one too wants to give something out. And they are both sufficient. They have sufficient electrons. So I don't want yours. I even want to give somebody. You want to be giving me. This one too is saying it. So definitely, you should hold your thing. Let me hold my thing. That is why they are not meeting each other. That is that as for this. Okay, let's look at negative charge too. You know, negative charge too, they will not meet each other because they are same charge. Radially inward for negative charge. I hope people are understanding my explanation like this way. Hey. You know, it's going in, radially inward. So now see. Should have made them closer to each other. This one also wants to accept electron from this one. But this one also wants to come and accept electron. This one wants to take electron in. This one wants to take electron in. This one wants to take electron in. They are looking for electron that they will take inside. This one is looking for an electron that it will take inside. That's why it came out. It's bringing it, filled out, extending it. This one too wants to look for an electron that it will take inside from another positive charge. But once the both of them discovered that they both don't have what to give each other, then they maintain their distance. So there is repulsion between them. See, we are Oloshi, me too am Oloshi. We are both deficient in this thing. We don't have money, we don't have electron. That is the meaning. Why do I come to you since you don't have what I want? This one is saying, why do I come to you since you don't have what I want? So they are both negatively charged and they are both looking for electrons. So there will be repulsion between them. That is what gives us the law of electrostatic. There will be repulsion between them because they have the same charge. Did I explain it? Did we guys get it? Or did you guys get it? All right. Why is it only Amino? Is it that she's the only one understanding me? And Ms. Abigail. Some of you even refuse to let me know if you got it right or not. It's up to you, though. I'm satisfied if I just see some few people. Shows they are with me. Okay, now look at this. Positive charge and the negative charge. Positive charge is looking for somebody to give. Negative charge is looking for somebody to take it from. You see, this one wants to radially inward, radially inward, radially inward, radially inward, radially inward, radially outward, 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 radially outward. Looking for somebody to give, right? Outward, radially outward, radially outward, and radially inward, looking for somebody to collect it from. Radially inward, looking for. You can see that this one wants to give. This one wants to give, it goes to this point. This one wants to give, goes to this point. And this one wants to collect, gets to this point again. Collect, it goes to this point. Collect, it goes to this point. Collect, it goes to this point. So definitely, this one is taking it in. This one is giving it out. So you have what I want. Let me come back with you. So you need what I have. Let me come and meet you. Then they met at the junction. There is an attraction between them. That is that. That's what happens for attraction between electrons. So these are the representation of lines of force, electric line of force, or field lines. They call them field lines too. So I think I've explained that actually. So any question, guys? Any question? It's already 10 o'clock. But let me just show you one thing. This is what we call Gauss's law. Over. Gauss's law says that the magnetic flux, which is phi, is directly proportional to the Q in an enclosed surface, provided that it is a Gaussian surface, and 1 over epsilon naught is the constant. We'll talk about it in the next class. Have a nice time. Thank you, everyone.
Thank you. God bless you.
Yeah, where you dey wrong go now? They never feel you don't carry board. You don't want me, you don't dey pray me, you won't finish on time.
No best, bro. No best, bro.
Just kidding, thank you. Hold on. Just recap the
Just the madness. I don't exhaust myself, you understand?
Abigail, can you ask your question like that?
She doesn't